My article for the hematology portion of our class this week was Red Blood Cells, the Forgotten Player in Hemostasis and Thrombosis. The authors presented evidence-based research on RBC effects in many areas, including bleeding, platelet activity, and a variety of concepts. And it was quite a thorough evaluation of the current literature. It's very well laid out. The authors speak to altered blood rheology, which is the flow and deformation of the RBCs, and they describe how it's variable in different physiological and pathological states. The three key areas they spoke to were alterations in hematocrit. We've long known that hematocrit levels considerably affect bleeding times. Low hematocrit, low bleeding times. High hematocrit, high bleeding times. And deformability is a variable that is very changing in the erythrocyte, and it's based on the hemostasis of the cell, the environment, and the overall health of the person. Deformability is accomplished primarily through membrane skeletal proteins and changes in the RBC membrane. Deformability changes the surface ratio of the RBC to the plasma and other components. And also, they speak to RBC aggregation, which is impacted by plasma proteins, surface properties of the RBC, and aggregation is impacted by inflammation, genetics, aging, free radicals, and proteolytic enzymes. Discussion, I just want to mention that the pathophysiology and the mechanisms of the development of a thrombosis include endothelial damage, hypercoagulability, and a disturbed blood flow. And you can see in the arterial thrombosis versus the venous thrombosis, the thrombi look quite different. The thrombi in the arterial system is impacted by a lot more platelet activation and aggregation and adhesion. There's a great deal of marginalization of the platelets in that thrombi. And the spheres of the erythrocytes are a different shape based on the high flow of the cell. You'll also notice that there's a lot of endothelial damage. In the venous thrombosis, it is also a high blood viscosity, but it's not so much the count, which is high in the arterial thrombosis, but the low aggregation of the RBCs that create the viscosity. And the RBCs altering their shape to pass through the microcirculation. And in summary, I would just say that there's a lot of impact that the RBC has, and the condition of the cell and the patient can make its adaptation, its ability to aggregate, deform, and manage hematocrit much more difficult.